Established in the 42nd U.S. Congress, the Yellowstone National Park, which is situated in the western United States, largely attracts many tourists for its magnificent natural beauty. But this time beyond the beauty, there's something different that came up through the scientists' research. After a long period, the experts come up with some indication. Something regarding the supervolcano. Stick to the end of the video, as you should also be concerned. Hello and welcome back to the channel. If you're new to this channel, join us by subscribing and don't forget to press the bell icon. In today's video, we'll share the details that the scientists shared regarding a sudden uplift that's happening inside the volcano system of Yellowstone. Without further ado, let's start. For indications of volcanic activity, the Yellowstone volcano is often watched. A collaboration between the U.S. Geological Survey, or USGS, Yellowstone National Park, the Universities of Utah and Wyoming, UNAVCO, the Montana Bureau of Mines and Geology, the Idaho Geological Survey, and the Wyoming State Geological Survey has resulted in the Yellowstone Volcano Observatory, or YVO. Scientists are looking for lessons from Yellowstone's past to help them answer that issue, and the outcomes are unexpected. They demonstrated that powerful forces can move considerably more quickly than volcanologists had previously thought. Early research, which was recently presented at a symposium on volcanology, indicates that the most recent supereruption of Yellowstone was started when fresh magma entered the system just decades before its eruption. The geological process that caused the catastrophe, according to earlier estimations, should have taken millennia to develop. So, there should be no reason to worry, right? Partly yes, partly no. The Yellowstone National Park was established in 1872 and is named after the yellow sandstone that can be found there. One must wonder how the ground lifts because the volcano, which is located in northwestern Wyoming, where the Yellowstone is contained, is one of the largest supervolcanoes in the world. Aside from being the location of a major volcano, Yellowstone National Park is also home to several additional hot springs and geothermal phenomena, including an active geyser field. It's also a wonderful place to see wildlife, including bison, elk, antelopes, wolves, and bears. Visitors can see steam rising from the ground, bubbling mud spots, and even geysers erupting. Yellowstone is quite distant due to its location, and its geothermal features can be hazardous. The Yellowstone National Park covers an area of 3,500 square miles, and it sits atop a volcanic hotspot. The majority of the park is in Wyoming, but some areas also extend into Montana and Idaho canyons. Yellowstone's characteristic features also include lush forests and alpine rivers. The supervolcano rests on a hot region composed of molten and semi-molten rock known as magma. When magma enters a reservoir or chamber 4 to 6 miles beneath Yellowstone National Park, the ground swells up. When the magma cools and solidifies, the ground sinks in. Volcanologists have been monitoring this volcanic activity since 1923, and they estimate that the ground rose 9.8 inches between 2004 and 2009 and 10.2 inches between 2010 and 2011. Supervolcanoes are defined as volcanoes that spew out more than a kilometer cubic worth of gas. Throughout 3 volcanic cycles that lasted 2 million years, the Yellowstone Plateau was created. 2 of these supervolcanic eruptions are among the most violent volcanic events ever recorded. The last eruption of the Pitchstone Plateau, which occurred 77,000 years ago, was limited to the caldera of what is now Yellowstone National Park. The first eruption, which created a 75-kilometer wide caldera and vicious volcanic deposits, happened 2.1 million years ago at the Huckleberry Bridge. The second cycle occurred when the Mesa Falls erupted 1.3 million years ago. Old eruptions that occurred in the Yellowstone region can be connected to the area that we now refer to as the southeastern part of Oregon. The Yellowstone hotspot has been stable for a very long time as the North American continent has drifted southwest. Interestingly, the supervolcano is responsible for the hot springs geysers in the park. Between 180,000 and 70,000 years ago, rhyolitic lava flows of 600 cubic kilometers gushed into the caldera at the Yellowstone Plateau, where the Lava Creek eruption created a 455 by 85 kilometers caldera. Nevertheless, during the Holocene, or the last 11,700 years of Earth's history, hydrothermal eruptions took place. A caldera is a bowl-shaped depression that forms when a volcano's magma or lava is ejected. It is about 34 miles wide. After the last eruption, the supervolcano went into dormancy. Over time, the caldera was filled with water and forestation started, and unfortunately, the ground suddenly started to sink. Many experts were concerned about whether Yellowstone will erupt soon and how violent the explosion would be due to the slow, steady buildup. The major concern, according to renowned volcanologist and University of Northern Colorado Earth Sciences professor Dr. Steve Anderson, is what would happen if Yellowstone began trembling tomorrow. Except for the southwest, where the eastern Snake River Plain extends to the southeast as a structural depression about 350 kilometers long. Between the northern and central Rocky Mountains, the Yellowstone Plateau's volcanic field forms the High Continental Partition. The plateau reaches an average elevation of 7,900 feet and is surrounded by mountainous terrain with peaks as high as 13,000 feet. Eruptions, earth collapses, deeply due to extremely thick lava flows, extensive faulting, and the corrosive force of water and ice. Yellowstone is currently an inactive volcano with low levels of restlessness, according to Dr. Jacob Lowenstein, a scientist in charge of the Yellowstone Volcano Observatory and research geologist. He also claims that there is no current activity going on that would indicate anything happening, and if something was coming, there is nothing to show at this time. In the broader Yellowstone region, magma from below the Earth's crust is present near the surface. The mantle's thermal convection is the cause of this small mass of magma. Rocks in the crust are melted by magma plumes as they rise through the mantle, forming reservoirs of partially molten, partially solid rock. Mantle plumes cause hotspot volcanism by transferring heat from the mantle's depths to the crust. As tectonic plates move over hot regions, a trail of volcanic activity is left in their wake. The volcanic hotpoint that currently lies beneath the broader Yellowstone area left a swath of volcanic deposits across Idaho's Snake River Plain when the North American plate migrated west during the past 16.5 million years. Rocks in the crust have melted due to heat from the mantle plume, forming two magma chambers of partially molten, partially solid rock close to Yellowstone's surface. A portion of the crust above the shallowest magma chamber expanded and rose as a result of heat. Increased earthquake activity was seen along freshly created faults as a result of stress in the crustal layer above. These faults eventually reached the magma chamber, where magma began to seep through the fissures. Magma escaping the chamber relieved pressures, which also allowed volcanic gases to escape and explode violently in large volcanic eruption. The eruption generated quick, extremely hot debris flows and pyroclastic flows over the pre-existing landscape, in addition to spewing large amounts of volcanic ash and gas into the atmosphere. The land above the subsurface magma chamber sank as it emptied, forming the first of Yellowstone's three calderas. Sour Creek Dome and Mallard Lake Dome may both have magma as close as 3 to 8 miles and 8 to 12 miles, respectively. Both domes experience uplift and subsidence as the amount of magma or hydrothermal fluids changes beneath them. The entire caldera floor also rises or falls, though not to the same extent as the two domes. The caldera floor has been tilted toward the south over the last century as a result of net inflation. As a result, Yellowstone Lake's southern sides have sunk, causing trees to now stand in water, and Fishing Bridge at the lake's northern end has risen to a sandy beach. Currently, Yellowstone is one of the planet's largest places with the highest density of geysers and hydrothermal systems. Yellowstone is one of the most seismically active locations in the world, with frequent earthquakes. Every year, 700 to 3,000 earthquakes, most of which are tiny tectonic plates, occur in the region due to the extensive network of faults connected to the supervolcano and the surrounding geological features. Two elevated places in Earth's past Mallard Lake and Sour Creek are the locations where the ground surface is being lifted and lowered. These locations are known as resurgent domes in geology. Huge earthquakes occur near the plateau, near the Teton and Hebden Lake faults. At present, the geologic activity of Yellowstone National Park is restricted to hot springs and geysers. A resurgent dome is a dome-shaped feature developed by the dilation or rising of a caldera floor due to a change in motion in the magma chamber beneath it. Scientists anticipate being able to predict future supereruptions as their research develops. It is unlikely that Yellowstone or any other supervolcano will erupt very soon. And we have reached the end. What do you think? Can scientists predict the next Yellowstone eruption? Or something worse will happen? Tell me in the comments below. To appreciate our efforts, like the video and subscribe to the channel. See you in another exciting video.